So let's discuss a question from thermodynamics. Basically, you have an electrical storage battery, which is our thermodynamic system, and it can exchange heat only with a constant temperature atmosphere. Goes through a complete cycle of two processes. So basically, it goes through a complete cycle, but there are just two processes. So let's just draw this arbitrary process 1, 2, and something like this. Okay. Now, and this is our electrical battery. So remember that work done by the system is positive and heat added to the system is positive. So going by this sign convention, we apply consider process 1 to 2. Work done, the heat addition Q1 to 2 is change in internal energy. Okay, that's 1 to 2 plus the work done between 1 to 2. Now using this sign convention, and let's see what is given. So in the process 1 to 2, 2.8 kilowatt hour of work flows into the battery. So work is done on the system. Okay, so this is delta U 1 to 2. Work is done on the system, so it's minus, and it's 2.8 kilowatt hour, that is per hour, this much watt. So hour is like, let's convert this into kilowatt or basically kilojoules. So this is kilowatt is like kilowatt hour is like kilowatt is joules per second into hour is basically we convert into seconds. So 60 into 60 seconds. So we have to multiply with 3600 in order to convert kilowatt hour into kilojoules. So 3600 and with the minus sign because work is done on the system, and heat flows into the battery, so that is positive. So 732. Okay, work is in while heat flow is out to the atmosphere, so that is negative. Sorry, that's negative because heat is not added, heat is removed, so minus 72. So delta U1 to 2, that is the change in the process, minus 32 plus 2.8 into 3600. So this is positive, and this change in internal energy is 9348 kilojoules. Okay, now let's see the process 2 to 1. Now 2 to 1, what heat transfer in 2 to 1 is equal to change in energy 2 to 1 plus work done in 2 to 1. Now remember that because the cyclic integral of internal energy is 0 because it's a property, so delta U 1 to 2 plus delta U 2 to 1 has to be 0, and because of this we can say that delta U 2 to 1 is minus delta U 1 to 2. Okay, because at the end of the processes, at the end of each cycle, basically you are at the same state. All your state variables are same, and internal energy is a state, is a property of the system. So all the properties are brought back to the same initial value which was at the start of the cycle. So at the end of the cycle you are at the same point where you are at the start of the cycle. Pressure, temperature, everything is same. Internal energy is also a property, it is also same. So delta U2 to 1 is minus 9348, and work is now let's see, 2.4 work flows out of the battery, so work is done by the system, so it's positive 2.4, and in order to convert kilowatt hour into kilojoules, it's 3600. 2.4 into 3600. So this value, what we get is minus 708. So that is basically so heat is removed from the system. So 708 kilojoules flows, that is the heat transfer. 708 kilojoules flows out of the battery. Okay, so the answer is basically 708. Thank you.